Like Alex said, my name's JJ. I'm a third year. I'm dual degreeing in theoretical pure math and information systems with minor in econ that I probably won't finish, but it's fine. So today I'm going to be talking about quantitative finance and financial engineering. I want to make this as interactive as I can, so I'm just going to be popping out some questions at some point. They're probably going to be super leading questions, but questions nonetheless. And here's what I'm going to talk about today. So the first thing I'm going to go over are types of financial firms, just so we can kind of get some base terminology on, where you might be working. And then I'm going to walk you through a very, very basic kind of like strategy from its beginning, from getting the data to the end, which is doing something with it. And after I get through these first 2 points, I'm then going to kind of hammer my point home of what working as a quant truly is, because there's a lot of misconceptions around the field that I'd like to undo within this talk. And the last thing I'm going to talk about is breaking into the job field, less about actually how to ace an interview, but more of the skills that you need so that regardless of what the interview is, you do well in it. Because the unfortunate reality is that a lot of these interviews are very bespoke. They change very, very often. In many cases, no two interviews are the same for any firm that you might work at. So learning about I think the skills that you need is the most important part, rather than trying to master the interview. But if there are any questions about it, I'll obviously touch on anything that you have questions on. And then I have 4 misconceptions sprinkled in there as well. But before I really ramble and talk a lot, if there's any just preliminaries, anything that you were kind of coming in curious of and wondering, I'd like to answer those questions just so I'm not spewing a bunch of information. But if you don't have any and you just kind of want to learn, I'm happy to do that too. But is there any initial things that anybody's kind of wondering off the bat, things that I could jot down? Yeah, what's up?
So do you think the theoretical math track is better than the financial math track?
Theoretical math. I think I might hit on that point, but let me write it down on the board so I don't forget. I'll just write TM versus FM. But that's a good point. Oh, is it not? Oh yeah, yeah. That's not really. I think it's the board actually. But theoretical math versus financial math. I think I will talk about that point. My initial answer is that it kind of depends, but there's not a huge advantage of just studying financial math when it comes to working in the industry, because you need the skills to do well. Financial math you sometimes learn on the job, but it can help. So I'll touch on that point. Hopefully, I think it'll be in bullet point number 3 or 4, one of those two. Any others? Yeah.
Techniques and technologies used as a quant, particularly.
Yeah, I will touch on that. Machine learning, I'll mention briefly at some points, but if I don't answer it to the fullest extent, then please ask me follow-ups. Any others that I could keep in mind, or anything else? No? Okay, so theoretical math versus financial, and tools, technologies, machine learning. Please keep those questions in mind. If I don't fully answer them, please follow up with me. But the first thing I want to talk about are financial firms, because a quant is somebody who works in a financial firm. So what are the financial firms? Many of you might know some of these, but it's always good to just kind of walk through it again. So the first type of financial firm that you might have heard of before are investment banks. Investment banks, if you're not familiar, these are banks for businesses. So if a business wants to buy a business, merge with a business, if a business wants to issue stock for the first time, all that sort of stuff, investment banks are the people who do that. And investment banks aren't necessarily just limited to that. They do a lot of other things. They do research on stocks. They do a lot of other stuff. But that's one example of a financial firm. Another example of a financial firm are proprietary traders. Proprietary traders are financial firms who trade with their own money and their own money only. So they're not really taking money from other people and being like, hey, give me your money and I'll invest it for you, make a profit and give it back. They say, no, we're just going to use our own money, and the money that we make, we're either going to pour back into the money that we're investing now, or we're going to give it in terms of salaries or employees. A popular example is Jane Street. I'm obviously wearing a Jane Street shirt right now because I did a program for them. But that is an example of a proprietary trader. And then there are hedge funds. And hedge funds are kind of the opposite in a certain way, which is that they do take other people's money and they say, hey, I want your money, I'm going to invest it, I'm going to do all sorts of crazy stuff to make money, and I'm going to give you it back in exchange for a fee. And hedge funds they can vary in terms of their strategies. A hedge fund can be very fundamental, where they use the classical field of finance and economics, the kind of fields that have been built up for many, many years now. They use fundamental analysis to talk about, I think this is a good investment because this is how the market works. Whereas I put on here hedge funds that are typically more quantitative, what you might see. Um, in terms of like where you might see more algorithms, more math, things like that involved in the process of investing, because they can totally vary. I found a healthy mix is somewhere between the two, using fundamental finance and also maybe more advanced technological techniques. But a hedge fund, once again, you're investing other people's money, and you're typically only taking money from very wealthy people and very big businesses who have retirement funds, or universities who have endowments, things like that. And then the other thing are consumer banks. Some of you might have credit cards with these consumer banks on here. Consumer banks, they're the banks that you and I interact with every day. So, they issue us credit. We borrow loans from them. They do research on their customers to make sure that, they're not giving it to people who are likely not going to pay them back. So those are some different types of consumer banks or financial firms. But one of the misconceptions that a lot of people think of when they think of the term quant is that you're only working at trading firms and hedge funds. When you think of quant, you're probably thinking Jane Street, Citadel, D. Shaw, all these firms. But a quant really, they work in financial institutions where you need STEM, science, technology, engineering, mathematics, to solve problems in the field. So that is one misconception that I think a lot of people have, and it can be very demeaning sometimes too, because these firms can be very competitive. But if you want to kickstart your career, you don't have to, kind of just like shoot unrealistically high, and then, you'll maybe land as, doing something else that's not really quant. But, you could be working anywhere, and I'll talk about some of the places that you could be working. So the next thing I'll talk about are kind of like the life cycles of quantitative projects. And what I mean by this is really kind of what it looks like to be a quant, or maybe, what you might be touching at different points of a project. So the first thing that you're going to be doing, like any sort of thing where you're working with numbers, is you need to get the numbers from somewhere. And depending on the firm, depending on where they are, they have many different places and resources to acquire data from. So there are places that acquire it directly from stock market exchanges. These places will be using wires that literally run from their business to the exchange fund, that can transfer data in faster than the speed of light. But there are other places that you can get data from too. Many places use APIs. Depending on what you do, you might be actually getting weather data. If a storm is coming in some country, and you predict that that's going to shoot oil prices up for that country, you could do something, buy oils, lock in a price, and then you don't need to worry about losing money, because you're making it off of people's misfortune. But that's kind of how finance works. And I put this picture of the Earth on there because, really everything and anything, any sort of data you can get, the better. You're talking like the purchases that people make, how much shirts JCPenney sold, how many students are getting enrolled in college, demographics data, all sorts of things. You're getting data from literally every single thing you possibly can to help you understand the worldview of finance. So that's the very first part of beginning a quantitative strategy. The next step is EDA. Has anybody heard of EDA or know what EDA stands for? EDA stands for exploratory data analysis. So basically you're getting data and you're just kind of seeing, what does it look like? What are the distributions of, returns of a portfolio over the last couple of years? What does this data looks like? Maybe you're doing statistical tests, t-tests, hypothesis tests, running ANOVA, regression, all sorts of, just very, simple and, moderately complex statistics to kind of feel out, okay, what's this data that I'm working with look like? After you go through EDA, you're going to be going through two different stages. So the first thing that you're going to be doing is actually developing a model. I think this is what people tend to think of when they think of quants, these kind of rocket scientists who are on a whiteboard, writing, I don't know, topological equations and, using all sorts of advanced concepts from theoretical physics or whatever to, make money. And I think that is kind of embodied in that stage right there, where you are kind of taking in all this data after you've done some exploratory analysis on it, kind of seeing, okay, this is what I might be doing. This is an idea that I might have. It might work. But the not so awesome thing about ideas is that they're just ideas. You know what I mean? Like what are you going to be doing while you're sitting around waiting for these things to be developed? So you're going to have people who are doing, kind of what I call model deployment, which is implementing ideas that have already been existed. So, if you're a researcher working on a strategy right now, there might have already been one made maybe a month or two ago, and you'll have your developers or whatever kind of implementing that. And then you also have your traders. These are people who are just kind of like working they work to make money kind of marginally on a day-to-day basis. So they're using very quick thinking, very sharp skills to exploit differences in prices and make money off of that. While you have your other people who are maybe developing algorithms and stuff like that to make money on a maybe more automated scale. And then lastly, like anything, you want to enhance your strategies, continue to refine them, enhance the technology that you're using, hold regular meetings to say, okay, is the hardware that we're using the most effective, combination of whatever to, drive high-speed performance, or, maybe you're just enhancing code that you've written that already exists, internal platforms and stuff like that. So that's kind of what it would look like from start to finish. But I want to ask, also, yeah, before I jump into that, I'm going to be talking about a lot of these. So when I say stage 1, stage 2, stage 3, and stage 4, it's kind of just like the order of which the strategy happens. So just to kind of like avoid me saying a bunch of words that I don't really need to say, I'm just going to call these stage 1, 2, 3A, 3B, and 4. But I wanted to ask, true or false, quants are the only ones working at stage 3A and 3B. True or false? What do you think? It's kind of a leading question, but yeah, it's obviously false. And the reason why is because quants work at all stages of the quantitative strategy development model. 3A and 3B are just the ones that you, once again, probably think of when you think of a quant, what a quant does. So I created this little labeling pattern here to kind of show you that when you say that you want to be a quant, you really need to specify what it is you want to be doing, because there are many different titles that a quant falls under. So when you're talking about the process of data preprocessing, acquisition, whatever else, you're probably talking about quantitative engineers. If you're talking about people who use analysis to kind of uncover patterns in that data, you're probably talking about quantitative analysts or quantitative strategists. The people who are doing the model development and the back testing, those are quantitative researchers. When you're talking about people who are doing trading, those are quantitative traders. People who are writing the code for it, quantitative developers. And there's like a few different types of quants. And my hope is that we'll get through all of these and talk to you about the skills that you need for each. So when you say quant, once again, know what you mean. So I'm going to walk through these kind of definitions here, and I'll talk about skills that you need. And I also put dollar signs to represent the salary comparative to the other ones that are on the list. So quantitative engineers, once again, you are using electrical engineering, computer engineering, and data engineering, as well as maybe some data science to help financial firms create the things that they want to do in the first place. Quantitative analysts, it kind of sounds exactly what it implies. You're using analytics, statistics, technology to understand financial markets and the data that you acquire. Quantitative researchers are going to be the ones who you probably think of. These are the people who are developing advanced models using many theoretical domains to either maximize money or minimize loss. Quantitative traders are going to be using analytics, mathematical thinking, arbitrage, game theory, very probabilistic ideology to make day-to-day trades. And then developers are going to be the ones who integrate financial strategies and models into algorithms. And when you hear people maybe talking about, like, if you ever heard like algos, algo trading, things like that, high frequency trading, HFT, the people who are implementing that code for that are quantitative developers. So depending on what you might be interested in, you could be working at any one of these stages, but we'll soon uncover that a degree in computer science or anything related to that is extremely helpful for any one of these fields. And don't let the $1 sign title scare you. There's good money in each stage of this. So don't think you're going to be broke as a quant engineer. So I want to answer the question that I think a lot of people in this room probably have, and that's, how do I become a quant? And unfortunately, there is no straightforward way. And there are a lot of harsh realities that I think people are kind of oblivious to when they first start working as a quant, because it's a very cool field and there's so many cool things to it. But I think a lot of people make the mistake of saying, okay, I'm gonna go to YouTube and look up top 5 books to become a quant. I'm gonna read those books and then I'm gonna go into an interview and I'm gonna nail it and I'm gonna have a job at Citadel. And unfortunately, that's just not true. So I'm gonna talk about some of these harsh realities. So the first one, financial math. So knowing financial math is extremely helpful because you're going to be learning the things that you are doing on a day-to-day as a quant. But whether you know financial or theoretical, I think in my opinion, it doesn't really matter, because it's more about the mode of thinking and the way you develop an idea from start to finish that matters a lot more. So financial math isn't exactly cutting edge when it comes to making a brand new quantitative research strategy. Because if you look at the degree path here for financial math, you're taking your Calc 1 through 3, your linear algebra, your ODEs and PDEs. You're taking Intro to Financial Math, Scientific Computing, and then maybe some I think you take actuarial science class and stuff like that. But if you look at the history of what has been developed in terms of quantitative models, a lot of these are using mathematics that maybe come from more pure fields. I think a notable one is one of the earlier algorithms that Renaissance Technologies, a hedge fund, they created, which used this, I forget the name of it, but some algorithm in computer science that helped them identify investment opportunities, and that was really profitable for them. So while financial math is very helpful, it's not going to be the selling point that, okay, if you study financial math, you will get a job here. I think you need a little bit more. It helps, but it's not the token into getting in. The one thing that I'm sure you might have heard of is the importance of networking when it comes to getting a job, talking to people who are in the field, getting referrals and things like that. But unfortunately, within the field of quantitative finance, you don't really network. Jane Street, you cannot coffee chat anybody there. They will not let you sign up for coffee chats with anybody. That's also the case with, I applied for a datathon at Citadel, and that was also kind of the same thing. So they're very merit-based, and when I say merit-based, unfortunately, sometimes that merit comes from studying at a tier 1 university. But that doesn't mean that you can't break into those fields from Ohio State. Don't let that discourage you, because I'm going to talk about things that you can do. But the interviews are designed to be hard. They're designed to, I think, undo everything you know about interviewing. And one thing that I think is another misconception that I don't have on this list, but a lot of people think that the quant interviews involve a lot of mental math and, okay, what's the cube root of, I don't know, 343 or something like that. I don't know if that's a whole number or not, I forget. But a lot of people think that you need to be good at stuff like that, when in reality you just need to be good at communication and thinking. I think a lot of the skills that you practice a lot for when you're interviewing for FANG or big tech or being a developer, anything like that, how you succeed in those interviews is very similar to how you succeed in a quant interview. But we'll talk about those, and if you have any questions, once again, please let me know. It's a waste of time to learn finance. Even though I just show you 4 different types of financial institutions, I contradict myself a little bit. You don't need to know anything about finance. You need to know literally, I think, nothing but having a general interest in it and kind of understanding the basics of how it works. But you're not going to have an inherent advantage over other applicants working in these firms because you like and know finance. Maybe as an analyst, maybe, but not for researcher, not for developer, not for engineer. This is another opinion that I have, and I think this is also another harsh reality, but it's the people who I notice who become quants intentionally, who build their entire degree plan and skill set around becoming a quant, are often the ones who don't get those jobs, as opposed to people who study pure fields maybe and don't really think about it until their last year. And the reason why I say that isn't to, I hope this doesn't scare anybody too much, but the reason why I say that is because I think a lot of mistakes that people make is they try to learn the technology or the tool before learning the reason why it was developed in the first place. And I think that's a big gripe that I have with AI, is I think a lot of, especially you see it in business, not, from the research or, CS side, but for the business side, you probably have experienced this. Maybe you're a business, I want to use AI. and they don't even have a reason why they want to use it. They just want to use it because everybody's buying, NVIDIA right now. So they're like, oh my gosh, like I want to know AI. And I noticed that kind of mentality is really crippling when it comes to quant. Like maybe learning the Black-Scholes equation before you understand how a partial differential equation is formed in the first place. You want to learn like binomial asset pricing without, really understanding the concept of probability models or lattice models in the first place. And I think that if you build up a really good skill set and then use that to learn the tools that you might need, and if I'm saying things that you have never heard of before, don't stress out too much. It's literally just like tools that are used in quant finance. My point is that like if you are trying to learn things before you understand why they were made in the first place, your understanding is going to be very shallow compared to somebody else who has taken the time to understand statistics maybe, and then they try to jump into learning the applications of the model. And unfortunately with quant research, as cool as it is, as like really, really awesome as it is, that's what I like. You can't really get one of those like fantasy full-time roles unless you have a PhD or an undergraduate degree where you've done like research and you have like publications and like all sorts of stuff. It's very, very hard to get those jobs, and that's important. It's important that they are hard because the things that you're doing, you're handling, millions, maybe billions of dollars using very advanced techniques. I mean, you can't just waltz into that role and just kind of learn on the job. You really have to acquire a very strong set of skill sets to succeed. But the last misconception that I have is that you can't get started. A lot of people think they can't get started on becoming a quant today. Even though the harsh realities that I have in the last slide are very, very true, these are, from what I've learned, from what I've seen, from what I've studied, from the professors I've talked to, from the workers I've talked to, and people who have these roles, these are things that I've learned over my time. But that doesn't mean that you can't get a quant research job after you graduate. You just need to do the right things to get there. And I'm hoping that through this talk, you can kind of maybe see the things that you might have been doing so far and take a step back or keep leaning into those things. But I hope that, maybe you can see the kind of things that you could do to do well and hopefully get one of these jobs. So let's start talking about those jobs. But I think I just want to take a breathing point right here and stop if there were like any questions or anything, because I didn't want to just run through the whole thing and then, I said something in like minute 2 and you had questions that, you wanted to ask it at minute 2, instead you're asking it like minute 30. So if there's any quick question I can answer before, yeah.
I'm not sure if I can cover this, but is it true like the quant interviews are always like really weird? Like give me some sort of like estimate within the order of magnitude of how many organs.
Yeah, yeah, yeah. That sounds like an answer. I can say when I did my program at James Street, the interview question that I had was I had to play a game with them, and that game they told me that basically there's like 8 people in a row, and each person takes turns rolling a dice. Person 1 does, and then person 2 does, and then person 3 does, all the way up to person like 8. And depending on the role that you get, you have like a score sheet. And the score sheet is like you mark it based on what you think might happen, depending on like your role and how you think other people's roles will play out. So for instance, if there's 8 roles and I roll a 6, I would maybe mark on the score chart that, okay, I think that the lowest or the score will be greater than 24 or something. I don't know. I guess not. I guess that wouldn't be a very good guess, but maybe like 14. I think the number will be greater than 14. And you kind of had to walk through with the interviewer. Okay, like how would you play? Okay, you just found out that this person rolled this. What do you do to adjust? Things like that. The interviews are like that, and so this summer I have an internship, and my interview was like that as well. I was asked like coding. I was asked like I was given it was really just like statistics, honestly, like Bayesian statistics, like just given that you have this information, what's the likelihood of this thing happening? So yeah, the interviews are like that, yeah. And I hope that'll cover that a little bit more, but did you have another one?
And like the advancing mathematics that people like actually like use quants like actually like or this like standard like well done techniques, because I've heard like things that talk a lot about data analysis exists. I'm not exactly sure how like effective they are.
Yeah, that's a very good question. That's something that I wondered for a long time myself, and I think the answer that I would say to that is I think when a lot of people hear that like we can stick with topological data analysis or like algebraic topology, um, they think that okay, like I am going to use algebraic topology to solve this problem. I think the way that, from my experience, it works is okay, I have this problem, I have this broad set of skills. Of these skills, I think that algebraic topology could solve this problem, and here's why. So it ultimately comes down to the problem and like the kind of best tool for the job type of thing that I kind of mentioned. Because in reality, I like maybe, yeah, maybe a problem could be solved with a simple, problem from linear algebra that maybe everybody in this room could solve for at some point when they graduate. Or maybe it takes something that's extremely complex, as like the theory of computing to understand how an algorithm will perform. So it really, really depends on, I think, what the problem is, and then the mission that you want to solve using this toolbox that you have. But these maths are they're very well used. I'm going to talk about some from statistics, from like higher level statistics that are commonly used in quantitative research. But yeah, so my answer is it depends. It can be, it may not be. It just depends on, I think, what you're trying to do. Does that help answer your question? Okay, cool. And if you have any more at any point, like please just shout out and ask. Okay, so let's talk about quantitative engineers. So a quantitative engineer these are going to be the people who are getting data. These are going to be the people who are engineering this data, making sure that it can, flow to the right places at the right time. These are going to be people who are accelerating the transport of data, making sure it comes at the fastest time it possibly can, because you need really, really fast time speed when it comes to getting data. Like you need data as soon as it comes out. And these firms, like they have insane amount of money that they can absolutely pay people to do this. So quantitative engineer are going to be people who are doing this. And so I use this notion of financial information systems, and to be completely transparent with you, I don't know if this is a term that's actually used or not, but a financial information system, I like to think of it as the design of how you I think like I kind of just said, get data to the right place at the right time. And how you export that data to different points, how you monitor the data, how you organize it, all sorts of things. I think that is the financial information system. So if this appeals to you, skills that tools and languages and technologies that might be helpful for you. A lot of people with the usage of big data use Java. For automating tasks, people use Python. For memory management and for high-speed performance, you might be using C or C++, depending on if you need object-oriented programming or not. Linux, it's obviously a big one, and then ELK, if anybody's heard of that, or ELK. I don't know if you say it like that, but it's a tool set that is used to, I think, monitor data, is the very Cliff Notes version of it. So yeah, you might be using more like lower level just technologies and more automative technologies. I don't know if that's a word or not, but technologies that automate things. You're going to be using those things to engineer the data that you get for the rest of the things that you do. And I think this is probably like my second favorite one after quantitative researcher. I just think it's super cool how you acquire data, and I think like engineer the pipelines for it to work with it. So I think it's pretty cool. I don't know a lot about this one, but it's something I'm actively learning about. I teaching myself some things to learn about it. So where you might be working if you are a quantitative engineer, you might be working at a hedge fund or a proprietary trader, because these are the people who need high-speed data the most. And salary expectations, obviously they depend on location and seniority, but for I think like associate, so entry level to maybe mid level, you could be making anywhere between 100 to 300K. The upper level is more for people who have a lot of experience and bring a lot of very good skill sets into the role. Does that make sense? Quantitative engineers, that makes sense? Okay, cool. So now you have quantitative analysts and strategists. This is probably more data analytics, if anything. It might not be, depending on what you think is exciting or not, this might be a very exciting option for you, because you're really just kind of using tools that you would use in a typical data analytics role, but for the purpose of helping quantitative strategists or quantitative strategies happen in the first place. So the places that you're going to be working if you're a quant analyst are going to be your investment banks and your consumer banks. I worked at JP Morgan for a summer. I was doing kind of like risk modeling and stuff, and they had this super big internal database where you could kind of meet any employee. You could just reach out to them. They had their emails there. And so I got kind of curious one day, and I was looking up like quant, and then I saw like a bunch of quant analysts. I'm like, oh my gosh, this is exactly what I think is cool. So I like sent him like, hey, like, can I talk to you? Can I chat? And he's like, yeah, I just use like kind of R and SQL all day. And I was like, oh, okay. Like I wasn't expecting that. So yeah, so quantitative analyst, if you're looking for like the LinkedIn job posting or something like that, it's probably going to be more of like a data analytics role, if anything. Some helpful, tools and technologies, and I know these aren't very comprehensive, and these are just very kind of like service level descriptions of these tools and technologies, but things that you might be using just from scouring the web and looking at job postings and stuff like that. Knowing data analytics, knowing how to mine data, knowing your descriptive statistics, your mean, median, mode. I think your like ANOVAs, all of those kind of statistics things that you might learn in like the engineering stats course here, or like your 2450 course here if you take that for stats. Those kind of things, you'll be using a lot. Knowing some UI UX, knowing how to make a dashboard and make it look visually appealing is very important. Knowing how to work with databases, obviously. And then some facets of artificial intelligence are used within the data analytics role, but specifically within the quantitative analytics role, from what I found throughout the internet, various things across supervised and unsupervised machine learning, a lot, especially in consumer banks. I think one of the most common things you hear of when you hear of machine learning is like classification and like churn rate prediction. That's a super common problem. Like what's or not churn rate, but default rate. Like what's the rate that a customer might default on paying a credit card given X, Y, and Z. So that is a problem that you would very likely be working on. I think that's actually the problem that the person who I talked to at JP Morgan worked on, which is super cool. And then web scraping and natural language processing to kind of understand, I think consumer sentiment is very important. But once again, these kind of roles are going to be working in large financial institutions. The salary expectations are a bit lower for this one. I say lower, you're still making more than the, most Americans, but it's 100 to 130K. I got these numbers just from looking on LinkedIn and looking for the websites for places. But the advantage about this one is it's a really great starting point to kind of leverage your position within other places in the company. So I think it's super cool. And then tools, tech, kind of everything that involves data analytics, Docker, depending on if you're, deploying out software and using the Bloomberg terminal. You don't really have to learn that, something you kind of learn on the job, but yeah, just some things that you might be doing as a quantitative analyst. I guess let's get into the juicier parts of it. At least what I think is super cool, which is quantitative research. So quantitative research is a very, very demanding or intellectually demanding job, I would say. I don't want to speak as if I have the experience to succeed as a quantitative researcher right now, because I don't. But talking to people and having like an internship in this, I can kind of say, I feel like I know pretty well what the general skills are. The first thing I would say is you need exceptional skills in mathematical modeling. So being able to take a problem and build a math model for it is so critical to succeeding as a researcher. Like that is what you do as a researcher. And so as part of that, having research experience is extremely helpful. Knowing, I think just like if you could even just be a part of helping a paper being published, knowing how that process works is I think very reflective of what it would be like to work in these firms. And the really nice thing about working in a firm like a proprietary trader, like up here, or a hedge fund over here, is that they really integrate so many resources for you to continuously learn and read up-to-date research on things going on in the field. It's it feels very academic to be there, and I really I like that, because I think academia is pretty cool. But yeah, so knowing that stuff, and I say theoretical subject knowledge because what I notice about theoretical subject knowledge is when you can really I think understand problems abstractly. I think it helps you think a lot more, and it teaches you this method of thinking that is very hard for me to explain, other than just saying that if you can understand the theory of something, I think you could do really well in quantitative research, because even if you get lost in the weeds of an intricate problem that maybe has a lot of parameters or something like that, you can know how to navigate through it and reduce a problem to something simpler. I mean, that's a skill that you learn in, theoretical math. It's a skill that you learn in computer science. It's a skill that you learn in even financial math. It's a skill that you learn in STEM in general. So knowing just how to master theory is very important. The type of computer science that I notice in quantitative research isn't as in depth as it would be if you worked in like software engineering, or as like a quantitative developer even. I think you just need to know like the basics of like your data structures and algorithms, how to optimize code to enhance its performance, and then knowing just like the theory of, I think, just okay, well, how would how would code with this many like classes or whatever, like how would this run, like what's the like space-time complexity, time complexity of like an algorithm, things like that. I don't really think you need to be well versed, like you don't need to be the best developer on your team as a quant researcher, but just knowing how to make, like, how to write good code really is all that it takes. And then knowing, like, once again, I bring up supervised and unsupervised machine learning a lot because that's just really what's used in these kind of roles. I don't really think that, like, things like generative artificial intelligence are used as much as these, things that we're working with data, because at the end of the day, like, you are working with data to predict, new sets of data. So machine learning is just what's going to be used. A strong knowledge of statistics is very important. I throw up some words up here if you're curious about any of these. I can answer maybe some questions. I'm not very like knowledgeable of all these, but knowing time series, regression, Copeland models, um, parametric statistics, Darsh models, all these different kind of things are important when it comes to knowing or exceeding in a quantitative, or excelling, I should say, in a quantitative research role, because at the end of the day, a lot of finance is just stats. That's really all it is. It's stats, it's probability. That's really all it is. I would say if your goal is to break into this after your undergrad, I would say be a part of some publications if you can, get involved in undergraduate research if you can. But obviously a PhD is strongly encouraged. A master's degree, it depends, because a master's degree is oftentimes a very specialized degree, whereas a PhD can be more abstract. And like I said, that theoretical thinking is very important. A master's degree can help. I think I know people with masters who are doing quantitative research, especially like the master's in financial engineering is a very popular one. I can answer questions if anybody has questions about that, because I've thought a lot about doing that myself. I don't think I will, but it's a good degree. But they can be very specialized. So if you really want to work in this field, like, I think having a PhD is extremely helpful. And the salary, as you would expect, I mean, is very lucrative. I mean, if you're working in quant research after your undergrad, I mean, it's a pretty easy 250K. I think that's what I saw from postings at hedge funds and stuff. And if you have a PhD, you could probably be making $1 million base salary a year, which is very, very nice. But obviously, the reason why is because what you're doing is very hard, and it takes a long time to get to that point. So it's very lucrative, and it's very, wow, it's really cool. But just, I think, know what you're getting into, know what it takes to succeed. And then obviously those are some technologies I think are most commonly used from job postings and stuff. For me this summer, I have to learn, I don't know a lot of C and C++. I have to learn that for the job. And then Python, cloud computing, I have to know. I have to use MATLAB, and I have to non-relational databases, as well as some big data frameworks. That's my experience, and I think that's kind of some other people's experience as well. So you could be using different things depending on the job, of course, but those might be some typical things. Okay, second to last thing here is quantitative trading. So this one I think is really interesting, because you don't really need to know how to code that much. I mean, you definitely should know. I think the level that you all will graduate with in this room is probably enough, I would say, to be really well as a quantitative trader. It's less about knowing how to code and be really good at math, but just knowing how to think. And so a lot of people don't really consider a career in quantitative trading. I didn't either, and the program that I did was actually in quantitative trading. And one thing that I noticed, that if you like things like math competitions and poker and logic puzzles and things like that, you could very well be a very, very good quantitative trader, because you have to take risks during the day. You have to understand like your risk tolerance. That example I gave earlier with the dice game is a very common kind of like way that you would be thinking about things as a quantitative trader. And so if your mind works like that and you really like those things, I think it's a really cool and fun field. Not really for me, honestly, but I can't really knock on it. I think it's super cool. And I put CSE as a really awesome major to have these kind of skills that you need, because the way that you break down problems and you learn to formulate solutions to problems is kind of a very identical point, a touch point to being a good trader. And I noticed that a lot of people who I was in the program with um, were CS and math. I think those were the two most common ones for trading. So if these are your majors or just interests that you have in general, you can very well succeed. But I also, I know people who like majored in classics and they're traders. It's a really like awesome field. It's again about the way that you know how to think. And I have some resources at the end, which hopefully could maybe get you some quick starts. Because I didn't really do a lot of math competitions despite being a math major, but I think that like knowing how to think about problems is very helpful. So I'll have some resources at the end that could hopefully give you some insight. And then the last thing are developers. I mean, everybody needs developers. So, I mean, you're going to be working at most places, but specifically within quantitative developers, I mean, it's kind of just like you're just building stuff for traders. You're building the ideas out. You're tinkering with ideas, you're improving them. So you can be working on more like high level systems. So you can think like algo trading. Most of it's done in Python today. Or low-level trading, low level programming, which you might experience working in system maintenance and in high-frequency trading. Most of that is entirely done in C++ and C. I know I've heard stories of people who have even just straight up programmed high-frequency trading algorithms in assembly. So that might be something that you could do. But those are kind of the two main domains I would say you're working in. The one thing I also put on there, I think I might have also had that bullet point on the last slide, is that, yeah, you need to be a really good thinker. A software engineering interview at Jane Street really looks like it's like the same thing as a trading interview, but you're just, instead of like talking about dice and, players playing games and stuff, you're talking about like an algorithm that you're building. So being able to like have a flexible thought process and just knowing how to like just think about problems and communicate and work with people are the skills that you need that are very similar to that of traders, researchers, engineers. Knowing your stats and probability is helpful, but depending on what you're doing, you might not need it. I would say that if you're working on more of like algorithmic trading, then yes, you should know that. And they might ask you questions about that in interviews. So really just when you're working in this field, just knowing application development and the full technology stack from, like the hardware to the software, I think is very important, just so you can kind of understand how a program would work. And you're building a lot of internal tools, so just keep that in mind. I found off of some job descriptions. I noticed people build applications in C# using like the .NET framework. Building applications in Java, cloud computing, Linux, all those sort of things that you will definitely learn by the time you graduate, or can teach yourself, on a YouTube video or so. So the last thing that I'll say on the note of interviews is that I would recommend when it comes to them to prepare for the interviews by preparing for the role. So I put some books up here, and I'll try to get these slides sent out at some point. These are very popular books that a lot of people on Reddit and stuff recommend when they talk about like, oh, these are books that you can do well. You can like learn how to read these, and you're kind of set for being a quant. And do I agree with that? I think so. I've read The Art of Problem Solving. I think that's a really cool book, and it's helped me. I think like a lot better when it comes to problem solving. But really, like, I would just say, like, go through these slides if you can, and just look at like the skills and the things that you need to do well in, and master those things. Like, master your major, master your minor, like master those things that like you are studying on a day-to-day basis. Because if you can do really well at just like formulating ideas and solutions, I think that no matter where you work in the quant strategy life cycle, that you will do well. And then like I would recommend, like, because some people are like, oh, like, what book should I? I read for like the programming that I'll be using. And at the end of the day, like I think if you can just be good at programming, that's enough. And just read books that cover like the area that you want to like leverage in a role, whether that's like a book on high frequency trading, whether that's a book just on like just your standard like programming book or whatever that might look like for you. Like I have a book on like deploying like Python strategies to the cloud. That has helped me a lot in like learning my stuff. So there's not really like a book I would recommend if you're like wanting to be a developer or anything. Just like know the field, know your skills, and just like get really good at the skills. I think that will show through. And obviously, like your lead code, would recommend that for anywhere, just like the same way you would prepare for like a FANG interview, like I said. So I have a little bit of a shameless plug here, and I'm not trying to steal any members away. But if you did want to get started and have this, I am a part of a group that does financial engineering research on campus. So if you do have interest in that, we can talk. But really, that was kind of it. So I'd be happy to like take any questions if I covered anything. If this was informative and if it helped one person in the room, then I'm happy. But yeah, did anybody have like any questions or anything else I could talk about? Yeah, what's up? Um, do you mean like where you're building these models? Oh, like types of machine learning models. I think for me, let me see. So I'm not an expert in this field by any means, but I have used a fair deal of it. So I've used things like random forests. I've used things like regression, clustering, classification. I want to see if there's anything else that I can remember off the top of my head. I think in terms of like specific things that you're using, yeah, I think those four are what come to mind for my experience at least. But there are people who are definitely more educated on like what tools technologies might be using. But I would say really that like I think if your goal is to like prepare for these fields by leveraging machine learning and like getting good at machine learning to use these fields, I would just say just like get started in supervised machine learning, because I think like just the topics in there are good enough to kind of like say, hey, I know this. And then unsupervised, it can be a bit more complicated. But yeah, so I don't know if I answered your question really, but was I just kind of like I think just those like four are things that like I've used, but yeah. Oh, deep learning. Hmm. To be honest with you, I haven't worked a lot in deep learning. Um, sorry to disappoint. Sorry if that's a disappointing answer. But yeah, I don't want to like make up an answer that's not fully accurate and tell it to you and be wrong up on stage. So I guess, I don't know. When it comes to deep learning, for me, like I haven't worked a lot with like deep learning or neural networks when it comes to like finance. I think the biggest thing that like I would just repeat and reiterate, and I'm sorry if this is like just dull information at this point, but like understanding the problem and then the technology. Because maybe there 100% probably is like deep learning that's used that I'm not knowledgeable of. For what purpose? I think it's just like what purpose would you need deep learning for? So yeah, I'm sorry if that doesn't really answer the question because I'm not super knowledgeable about like all the machine learning that's used. I just kind of know like the things I need to know. But I definitely want to get more knowledgeable at some point. So if you want to talk about it at some point, we could chat. But did that help any like a little bit? Yeah, a little bit. A little bit's the best I can do. So, but yeah. Cool. Any other questions on just like anything I went over? And this is a lot of information, but yeah.
Okay, I talked about how to prepare and work during the interview at the quant firm.
Yeah.
But how do I get an interview at a quant firm, especially as an undergrad intern?
That's a really good question. I think it starts, I would say like anything, like any job that you would interview for, I think talking to the recruiter is always a very good first step. If that's common knowledge, I'm not sure if that is common knowledge in this room, but getting to talk with a recruiter who's hiring people in these positions are always really great. They might take a coffee chat. They might not, but if you could ask any preliminaries, I think that would be really helpful. I can speak to Jane Street. I really, really, really like their hiring process because they will read every single resume. And for me, I think I have kind of like an unconventional background. I studied pure math and I've had some research experience and I'm doing research right now in operations research. And I've worked on some projects before that are financial, but not entirely. And I think they like that for the trading interview. So I think breaking into the role and like getting the interview in the first place kind of relies on, I think that experience that I recommend you acquire as an undergrad, getting to do things like research, I think is very important. But for trading and development and developer roles and stuff like that, I would say just getting to talk to recruiters, understanding the skill sets that you need. So kind of working backwards in that regard. Entering some like math competitions at your school if you can to have that on your resume or hackathons or things that Dev might put on. Those kind of things. I think project experience is also very, very, very helpful as well. But I would really say, so that would be more for trading and engineering, I would say. And then for quant developers, in my opinion, and this is just my opinion, as is everything in this presentation, but I would say that I would prepare for those and like try to recruit for roles in those industries, in those fields, in a very, very similar way that you would be doing to become like a software engineer at like a big company. Because those interviews are also difficult to get. But if you are like if that is your career goal, then you kind of are familiar with the path and like how to get those. I would hope, and you can always learn more about it. But I would prepare for those like the same you would do. So yeah, just building up the skills, getting project experience, getting some research down, and then applying in the same way that you would for another firm if you're looking to be a developer. I would say is probably a big point. So, yeah. Was that helpful? Okay, cool. Yeah. Any other questions? Anything I can answer before I hop off? Yeah. What's up?
How's the work-life balance of some of the big firms?
It's great. It's really great. I mean, I know for trading and for research, it's probably a cool 9 to 6. For developing, I've heard actually a couple different things. I have a friend who worked at Citadel, and I know that he was very like pressed for time, to put it lightly. I think he was probably working like an 8 to 8 at Citadel, like, which is that can be a lot for sure. But at least for when you're in the full-time job and you kind of like establish a good history and stuff, it's a pretty good balance. It's for most places. So markets in the United States, markets in the US open at 9:30 and they close at 4. And so you need to get in a bit early to prepare for when the markets open. And then you need to be there after to like what's called closing your books. So reporting on like trades that you've made and things that you've done, and then you're kind of out of there after a couple hours of that. So it's pretty good balance actually. And that's one of the reasons why I really recommend it. Great benefits too. Also, Jane Street offers free food and I don't know. I mean, I know so many people offer free food, but whenever I see free food, I'm like fuck yeah, like I love free food. So So yeah, but yeah. Anybody else?
Is quantitative trading a glorified version of day trading?
I would say it's a glorified version of like poker. I would say that because it's I think with day trading, it can be very like I don't know, not a lot of thought can be put behind day trading, for the average day trader, whereas in quantitative trading, it's a lot of like the same like ways of thinking that you'd be learning in like a competitive card game. So I would say it's like glorified like poker. Yeah, that's what I would say. Yeah. I know we're about to hit 8 o'clock, but yeah, I wanted to thank you all for listening to me for a bit. And yeah, if you had any interest in learning more about these fields, feel free to talk to me about OB McFarlane. I think it's super cool. Not trying to steal any dev members, of course. It's only like an hour a week, but yeah. So thank you all. I think that's it. Yeah.